So now the next thing we are looking at is functions. Right, you have already seen you can write the function as fx, gx, hx, you can use any variable. So fx means function of x. If I write fy, that would be a function of y, right? If I have to take example, let's say x squared plus 3 and fy would be y squared plus 5. One is a function of x, one is a function of y, right? So what we have to understand according to the start point of view is composition of functions. So if I have fx is equal to x plus 2 and gx is equal to x squared minus 4, in this case, if you look, if I want to find out f of gx, that means the first thing I have to do is replace x with gx, right? Replace x with gx. So if I replace x with gx, I'll write g of x plus 2. But what is g of x? G of x is x squared minus 4. So x squared minus 4 plus 2, that becomes x squared minus 2, which is f of gx. What is f of gx? F of gx is where when you replace x with gx. Let's say if I want to write g of fx. Now, what would be g of fx? You replace x with fx in g. So x squared, that means x plus 2 whole square minus 4, and this would be x squared plus 4, 4x minus 4, this gets cancelled, so x squared plus 4x. All right. Same thing can be asked in the form of table. Same thing can be asked in the form of graph, right? So if I ask you what is f of 3, so f of 3, you replace x with 3 in the function f, that would be 5. What is f of minus 2? So in the place of x, you write minus 2, that would be 0. What is g of 2? G of 2 is 4 minus 4, that's 0. Again, right? Now, let's have a look at the remainder theorem. So what is remainder theorem? Remainder theorem is basically, I can write this as 2, 3, 6, 1, right? And there 2, 3, 6, 1. So this, I can write the first one as 7 is equal to 2 times 3 plus 1. For this one, I can write 7 is equal to 3 times 2 plus 1. Now, in this, what is important to understand that it does not matter if you change the position of these two. It does not matter, right? Here, if you look in the division, first I divided by 2. So at the top, I got 3. Now, in the second case, I divided by 3. At the top, I got 2. It doesn't matter to the remainder if you change their position because remainder always stays the same. All right? Remainder always stays the same. What happens when it's polynomial? Exactly the same thing happens. Nothing changes. It doesn't matter. If you change whatever you're dividing it by, remainder stays the same. Okay. Now, let me, okay. Again, I'll take fx is equal to x squared minus 5x plus 6. Okay. So I can also write it as x minus 2, x minus 3. Now here, if you look, what are the factors of fx? Okay. What are the factors of fx? Factors are x minus 2 and x minus 3. These are the factors of fx. Okay. If factors are x minus 2, x minus 3, how do you get the factors? So you look at the roots. What are roots? Roots are 2 and 3. So if 2 and 3 are the roots, factors would be x minus 2 and x minus 3, right? Now, if you divide fx by its factor, if you divide fx by its factor, remainder would be 0. This is important to understand. Why remainder would be 0? Let's look, for example, if you have number 8, what are the factors? 2, 1, 2, 4, and 8. These are the factors of 8. If I divide 8 by 1 or 8 by 2 or 8 by 4 or 8 by 8, in all these cases, remainder would be 0. The same thing happens with the polynomial. If you divide a polynomial by its factor, remainder would be 0, right? So if I try to divide x squared minus 5x plus 6 by x minus 2. So the first thing I'll do, I'll multiply it by x. It becomes x squared minus 2x, right? You cancel it out. You subtract it basically. So you get minus 3x plus 6. You take minus 3. Minus 3x plus 6. And it comes out to be, again, you subtract it. So it comes out to be 0. How can you write it? You can write it as x squared minus 5x plus 6 is equal to x minus 2, x minus 3. Now, the second thing you have is, you remember I said it doesn't matter if you change the position, right? Now I'm dividing by x minus 3. What should I get at the top? I should get x minus 2 at the top. So x squared minus 5x plus 6, right? First you do x, you get x squared minus 3x. Again, you subtract. So you get minus 2x, this gets cancelled, plus 6 minus 2, you get minus 2x plus 6, you subtract, this becomes plus minus, remainder is 0 again. So again, what can you write? You can write x squared minus 5x plus 6 plus 6, right, is equal to x minus 2 and x minus 3. So what I want to say here is basically that it does not matter if you divide it by a factor. If you divide a polynomial by its factor, remainder would be 0. Right? So what will happen if it's not a factor? Then that's a different thing to look at. Right? Let's see. So let's say if I have x squared minus 5x plus 6 and I divide it by x minus 1. Definitely x minus 1 is not a factor because it can only have two factors. Why? Because it can only have two roots. Right? So first x, I'll get x squared minus x, subtract it, minus plus. This gets cancelled, you get minus 4x plus 6. So minus 4 minus 4x plus 4 plus this becomes 2. 2 is the remainder, right? Now, how can I write this? Square minus 5x plus 6 is equal to minus 1 x minus 4 plus 2 remainder, right? How did we write that? It's 7, 2, 3, 6, 1. You can write 7 is equal to 2 times 3 plus 1. You multiply these two and add the remainder. In the polynomial, multiply these two, add the remainder. You have the exact thing, whatever you put in between. You can also write it in one more way. Yeah. And what is that way? That is basically, all right, x squared minus 5x plus 6 over x minus 1, because you were dividing it by x minus 1. What do you get? So that means basically you divide everything by x minus 1, you get x minus 4 plus 2 over x minus 1. If in this equation, if you divide the entire equation by x minus 1, you get the second equation. So both the equation are exactly the same. There is no change. But in the first equation, remainder is 2, this 2, which is sitting idle. In the second equation, remainder is this 2, which is divided by x minus 4. So this is something which we have to understand. Which one is the remainder, in which case, according to the equation given to you, you have to identify the remainder. Now, with this, a very important point comes. Okay, I said that if you divide a function or a polynomial, let's say fx is equal to x squared minus 5x plus 6, right? X minus 2, x minus 3. If you divide it by, what were the factors? X minus 2, x minus 3, because 2 and 3 are the roots. If you divide it by x minus 2 or x minus 3, since they are the factors, so remainder would be 0. Okay, so if I put x equal to 2 or x equals to 3 here in this, what is going to happen? F of 2 would be 0, f of 3 would be, right, because they are the roots. So y value has to be 0, right? Now in this, if you look at it here, our remainder came out to be 2, which means if I try to find out if this is fx and if I try to find out f of 1, I'll let you know what, because see, here you're dividing it by x minus 1. In the factors, you were dividing it by x minus 2 or x minus 3. So I found out f2, f3, right? In both the cases, remainder would be 0. Here, since I divided it by x minus 1, so I am finding out f1. f1 in this case would be 1 minus 5 plus 6. That is minus 4 plus 6 is equal to 2. So from here, what do we understand? Let's see. If you have, a polynomial divided by x minus k, it doesn't matter it's a factor or not, okay? If this is the case, your remainder would be f of k, right? For example, if I divide fx by x minus 3, f3. If I divide f of x over x plus 1, your remainder would be f of minus 1. Here, what you do? You put x plus k is x minus k is equal to 0. So you get x equals to k and you find fk. In this one, x minus 3 is equal to 0. So you get x equals to 3. You find f3. And this x plus 1 equals to 0. You find x, you get x equals to minus 1. You find x f of minus 1. This would be the remainder, right? Now, one type of question that you will generally get is they will say that, okay, there is a function px and p of minus 1 is 0. So what do you figure it out from this? What I figure out is, first of all, p of minus 1 is 0. That means p, or that means minus 1 is a root, right? Because f of at what x y value 0, that is a root. That means minus 1 is a root, which means x plus 1 is a factor, which means if I divide px by x plus 1, remainder would be 0. Now, let's say there is a function kx, another example, and k of 2 is 5. In this case, 2 is not the root because k2 is 5. So 2 is not the root. X minus 2 is not the factor, which means if I divide px over x minus 2, remainder would be equals to 5, right? All right, guys, please ask if you have any question with this remainder theorem. And you can also let me know if I'm going too fast. But, since you see, I tried my best because we are only getting 4 weeks. So one module per week. I have to go fast in order to, cover up at least everything. So that when you do the sheet, and it's already 7:36, so we do not have much time to do the sheet here today, right? But still, we'll try a few questions what I've sent, and then we'll take it from there. If you guys have any question, please let me know.